Good morning. Today we're going to sketch two polynomial curves, and with the aid of differential calculus, we can see clearly how we can accurately sketch the curve. No? So we have two problems today, and the first one is y is equal to x cubed minus 3x. So first thing to do is to examine the leading coefficient test, no? At x is equal to at x cubed, no? So as you can see here, the coefficient is positive and we have a degree 3, no? So add degree, no? So after knowing that, we get the y-intercept. We set x first to 0. If we set x 0, we get y is equal also to 0, no? For the x-intercept, we set y equal to 0. And then get the value of x. No? We get the value of x, three values of x, 0 for this one, and x to be plus or minus negative 3. So we have three values. The square root of 3 is 1.732. So we have here this graph here. We get the y-intercept to be 0. And the x-intercept to be 0, and square root of 3, 1.732, and also this one, 1.732. And then we get the critical values for which we will base our maximum and minimum point, because the slope y prime is equal to 0 at that point. So y prime, we differentiate the given value of x cubed minus 3x. We have here 3x squared minus 3. And then we get the value of x. X is equal to plus or minus 1, no? The square root of 1. So we substitute this to the original equation, the given equation y is equal to x cubed minus 3x. If we substitute to get the value of y, so we get it to be y cubed minus 3 is equal to negative 2. At x, no, the other value of x. No? So we have here negative 1 cubed minus 3 times negative 1. So we have here negative 2. Or positive 2, I mean. So we have two values. The minimum is at x is equal to at x is equal to 1 and y is equal to negative 2. No? This will be the minimum value. And for the maximum, we have here a maximum value at negative 1 and y is equal to positive 2. So this will be our complete graph, no? For this equation here, y is equal to x cubed minus 3x. So we get another polynomial, y is equal to x cubed minus 3x squared. And we get again the y-intercept. We set x to be 0. We get here y is equal to 0. And for x-intercept, we set y to 0. And we get 0 and 3. So we have 0 and 3. Two x-intercepts. For critical values, again, we differentiate, no? This equation here, the given equation, at x cubed minus 3x squared. So if we differentiate that, we get here y prime is equal to 3x squared minus 6x. And then we factor out 3x. And what remains is x minus 2. So we have two values. At x is equal to 0 and positive 2. At x is equal to 0, y will be equal to 0. We substitute that in the original equation. No? At x is equal to 2, if we substitute that the original equation, we get negative 4. So this will be our minimum point at x is equal to 2 and y is equal to negative 4. So for the maximum, that will be 0 and 0. No? As you can see the graph, from this point here, upon reaching the minimum value, it goes up and reach the x is equal to 0. And then goes down again to a very deep value for y. No? So for this graph alone, the minimum is 2, -4, and maximum 0, 0. So that's how we can practice sketching polynomial graphs. First, you get the leading you perform the leading coefficient test at the first leading term, and get the intercepts, and then we get the critical values and substitute whatever critical values we have for x, so that we can see the maximum minimum point. No, then we can graph now. No? So thank you for watching this video, and please don't fail to subscribe to my YouTube channel, and also click that bell icon. So thank you, and see you again later.